In the last section, we had a long demo of Redux. We're going to continue in this section by trying to answer that one burning question that might be in your head, which is, why in the world would we ever write code like this? What's the point? Why do we have actions and reducers and stuff? Why don't I just split this string and be done with it? Hey, that's a fantastic question, and that's probably the most important question there is with Redux. All these actions, reducers, store stuff, what is the point of it? Let me tell you what the point is in one sentence, and I'm going to try the rest of this course to convince you of this one point. Redux is one of the best libraries in existence for scaling an application to be very large with the least amount of code complexity. In other words, as your apps start to grow, start to get more features, Redux will help you write code in such a fashion that your code doesn't also have to grow in complexity. So that's the point of Redux. But why is that the case? How can I make that claim? Easy. I can easily make that claim. The answer is the action system. This whole process of dispatching an action and receiving it inside the reducer. With Redux, actions give us the ability to make predictable changes to the state of our application. We will never ever reach directly into our store, reach directly into this thing and start messing around with a state that is contained within it. Instead, we will create an action, and actions modify our state in one very particular way. That means that we can only modify our application state in a very finite number of ways. Now at this point in the app, I can only change my state, my state object, which I retrieve via store.getState, in exactly one fashion, via the action that we wrote right here, the action with type split string. Because I only have one action, I know without a fact, with absolute guaranteed certainty, that my application will always have a state of either empty array or, and I think I lost a get state on here. Let me throw it back in really quick. My state is always going to be either an empty array or an array with some strings inside of it. That's it. My state will never be an object, a string, a number, a Boolean, nothing else. I will only ever have an array or an array of characters. That's it. Now that's my case for using Redux, but for right now we should be a lot more concerned with exactly how it works. So let's review the code that we've got so far. First, we created a reducer. Lost my spot. There we go. First, we created a reducer. A reducer is a function that produces some amount of state, remember? Then we created a store and passed it that one reducer. So we now have an instance of a store that contains one reducer and the state that that one reducer produces. So by default, if we call getState on that store, we got back an empty array because that is what the reducer produced. Next, we made an action. The action is a very specific directive to tell the reducer how to update its state in a very particular fashion. So our action was of type split string. The type right here you can think of as being like the command or the direction that we're issuing to the reducer. And then we also passed along a payload property. The payload property is the data that we want to communicate to the reducer. So we can read this action in plain text more or less as, hey reducer, please split the string, and here's the string that I want you to split. Next, we sent that string off, or that action off to all of our reducers by calling store.dispatch with the action. When we dispatch an action, as we refer to it, the action will get automatically sent to all of the different reducers inside our application. So let's experiment now by adding another action. I want to make an action that will take my current array of characters, which is ASDF, and I want to just add another character at the end of this array. So I just want to have an action that modifies my state by adding another character to the end of the array. So first we will define an action. So I'll write out my new action, and I'm going to call it very simply action2. Remember that actions are objects. They must have a type property. I'm going to give this one a type property of add character, and then a payload of A. So if I read this read this in a very literal fashion, I would read this action 2 as meaning please add another character to the end of my state array, and that character to add should be A. Okay, so that's basically the idea here. So now we're going to dispatch this action. Remember that by just creating an action, nothing actually occurs by just creating one. We have to actually dispatch it. Dispatching an action sends it off to our reducer. The reducer will rerun, and whatever this reducer returns becomes our state inside of our store. We can then retrieve that state by calling store.getState. So now we're going to dispatch the action by calling store dispatch action 2. Again, when we pass an action to the dispatch method, it gets sent to all the reducers that are hooked up to our store. In our case, we've only got one right here. Our reducer will then immediately rerun, so this reruns right here, and return a new updated piece of state for the store. Notice though that even though we added in another dispatch, let's check our state really quick. If I call it store.getState, my state inside of my store has not actually changed. So nothing has occurred yet. I still just have a state of ASDF. That's all there is right now. So notice our reducer has decided that it does not care about the action that was dispatched, so it just ignored it entirely. This is a really important fact. It means that if we have multiple reducers in our application, each reducer will be called with every dispatched action. So it's up to us to make sure that this reducer right here watches for actions of a very particular type. So in our case, we want to make sure that this reducer also responds to an action of type add character. So to do so, we'll add another if statement in here, or another catch. Let's say else if action.type equals add character. Then I want to add that character to the end of my array of characters right here. Okay, so like this ASDF. That means that I need to already know what this reducer returned the last time it ran, right? I need to know, okay, I already dispatched one action and my current state is ASDF, and now I intend to add on a character to the end of that array, a character A. So how do we get access to that previous array? How do we get access to like that previously calculated piece of state? That is the job of the first argument to the reducer, which we have labeled as state here. Reducers rerun many times throughout our application, and each time they are called, they are passed the result of the last time they were called as the first element, which we, by convention, refer to as state. So again, each time we dispatch an action, we are making an incremental change to the state of our application. So now inside of here, we'll take our state and we'll push on action.payload and then return that modified state. Now our getState call returns ASDF and A. So A is the new character that was appended at the end. Let me pause for a moment though, and I want to say that I just made a huge error in the code that I just added right here, something that is very subtle. I want you to take a look at the two lines that I just added. I took my current state object, and then I added in another character to it using push, and then I returned that object. Now, sure, this seems like an okay thing to do, right? Like, Stephen, you said we need to add in a character to the end here. Not quite. So this is the one big rule of reducers. Whenever we change our state object in reducer, so like whenever we make a tiny, very subtle change, we must return a completely new object or a completely new array or whatever data structure we might be using. In other words, we do not mutate our data as we did right here. Instead, we create a completely new data structure. The code that I wrote right here mutates our existing state array by calling push on it. So I'm taking this existing array and I'm modifying it, which is not what we want to do. We are going to, in a future section, we're going to talk in great detail about why that's the case. For right now, I just want to kind of plant it in your head like this kind of like seed of a thought that we do not mutate our state in a reducer. Instead, we completely recreate it. So to fix this, I'm going to replace these two lines with a little bit of ES6 code. I'm going to instead write return, and then I'll open up an array, state, comma, action.payload, and then close off the array like so. This line right here now says, make a new array, indicated by these outside brackets, take all of the elements in the current state array and toss them in here, and then also toss in action.payload as the last entry as well. More importantly, it creates an entirely new array, which is the requirement that we must satisfy with Redux inside of a reducer. Now again, we'll talk about why this is the case in the future, but for now, just remember the golden rule. We always return brand new objects from reducers. Okay, so believe it or not, I'm sure you're still incredibly confused, but this is the end of our very brief introduction to Redux. So I absolutely, in no way, shape, or form, expect you to be a master of Redux at all. Not one bit. And in fact, I'm going to continue in the next section by assuming that you know absolutely nothing about it. Redux is tough, it's hard, it's a different way of thinking, so we're going to take things nice and slow. The only intent I had inside of this section and the previous sections was to introduce you to the ideas of a reducer, an action, dispatching actions, and pulling state out of our store. Okay, so those are the big takeaways here. That's all I really wanted you to get out of this. We're going to continue now in the next section, and again, I'm basically going to assume that you know nothing about Redux anyways. So let's continue on the next application and continue working on our actual React Native application. I'll see you there.